Hello everyone, my name is Edanaz Ateş. I am a chemistry student at Bilkent University. In this video, I will describe my Physics 101 laboratory project. My aim in this project is to observe law of conservation of momentum and energy by using Newton's cradle. Now, I will explain my equipments and procedure used in this project. As you can see in the screen, this device is known as a Newton's cradle. It consists of 4 identical spheres suspended from thin strings. To begin the experiment, I released a single sphere and allowed it to collide with the others. When one sphere was released, only one sphere on the opposite side rose. The maximum height reached by this sphere was approximately equal to the initial release height of the first sphere. This observation is consistent with the principle of conservation of momentum. Similarly, when I release 2 spheres simultaneously, 2 spheres on the opposite side rose. The height reached by these spheres closely matched the initial height of the spheres I released. This further demonstrates that the momentum and energy transferred through the system and conserved in an ideal scenario. Now, I will explain the principle behind this and why both the initial and final heights are approximately equal. Momentum is a vector quantity in physics that deals with motion. It is proportional to objects' velocity and mass. When no external force is applied on the system, according to law of conservation of momentum, the initial momentum of the system remains constant. That means there is no change in momentum. When an object collides with another object elastically, it transfers all of its energy and momentum to the other object. The Newton's cradle is the one experiment that proves these two laws of conservation simultaneously. It consists of identical balls suspended by strings so that they could barely touch each other. When a ball lifted and released, it strikes the next ball and stops, while the same amount of balls swing out on the opposite side. This motion shows that the energy and the momentum of the first ball transfers these quantities through the balls to the last one. To obtain the data, I measured the initial height and the final height in each trial. Using these values, I calculated the velocity and momentum of each ball. My calculations show that momentum was conserved in every trial. However, since the system is affected by air resistance and friction between the spheres, some energy is lost. These effects cause a portion of the mechanical energy to be converted into other forms such as heat and sound. Because of this energy loss, the spheres do not return to their original height after each collision. Instead, the maximum height gradually decreases with every swing. This observation shows that in an ideal Newton's cradle with no external force or friction, the balls would continue oscillating at the same height indefinitely. But in a real setup, these non-ideal factors reduce the system's energy over time, which explains the damping motion observed in the experiment.